Dear students, this is Praveen KM, and in today's episode we will discuss some of the important concepts from two chapters. They are number 1, motion in straight line, and number 2, motion in a plane. These two chapters together carry some 2 to 3 marks on an average in Karnataka CET and other competitive exams. So, let's go to questions directly. Probably I have tried my best to select the questions in such a way that they cover almost all important concepts of these two chapters. Let's go to questions straight away. To start with, I have taken a simpler problem. It goes like this: a particle starts from rest and travels a distance x with uniform acceleration, then moves uniformly a distance 2x and finally comes to rest after moving further 5x with uniform retardation. The ratio of maximum speed to average speed is options 5 by 2, 5 by 3, 7 by 4 and 4 by 7. I think this is the problem based on average speed. Probably the VT graph, velocity time graph, will help me to solve this out. Let's try to write VT graph for this. Look at this. Initially, okay, it starts moving with uniform acceleration. So, VT graph for a body which is moving with uniform acceleration should be a straight line upwards. Since the acceleration is uniform, it should be a straight line upwards, and it reaches a maximum velocity. Remember, it has started its velocity from 0, it has reached a maximum velocity, let me call it as some v, and this happens up to a time period t1, let me say till t1. It moves with uniform acceleration. Further, it moves with uniform velocity uniformly for some time interval, let me say for some t2, and further it finally retards and finally comes to rest. So, when it retards, the VT graph should be a straight line downwards like this. So, let me say that this time interval is t3. I hope this is clear. Now, what are we supposed to find out is average speed and also the ratio of this maximum speed v to average speed. Okay, I hope you are familiar with the average speed formula. It is total distance divided by total time taken. What is total distance? It is quite simple. During t1, total distance covered is x, then during t2 it is 2x, and during t3 it is 5x, if I am right. Yeah. So, the total distance will not trouble you much. It is x plus 2x plus 5x is just 8x. But the idea is, how do you find out total time taken, that is t1 plus t2 plus t3. Let me write the formula first. Yeah, average speed v average is given by total distance divided by total time. Total distance is quite simple. It is x plus 2x plus 5x divided by total time t1 plus t2 plus t3. Now, my task here is to express these t1, t2, t3 in terms of x. So, how do I do it? I hope you are familiar with the fact that the area under VT graph will give you displacement. So, what is the area under this graph represent? What does this represent? So, this is the distance covered during t1. It is mentioned that it is x. So, area under this triangle is half into base into height. It is x is equal to, that is the distance covered during t1 is equal to half into height is v into base is t1, half v t1. Similarly, during second time interval, distance covered is 2x. It can be written as, yeah, since it is a rectangle, it is v into t2. Next, during third time interval, it is 5x is equal to half into v into t3. So, from these three expressions, I can get the expressions for t1, t2 and t3. So, t1 is equal to 2x by v, t2 is equal to 2x by v, and t3 is equal to 10x by v. So, substitute for these expressions in the expression for average speed, that is v average is equal to 8x divided by 2x by v plus 2x by v plus 10x by v. So, this is 8x divided by 14x and v goes to numerator, v 14x. So, this will be average speed is equal to x gets cancelled. This is 4 by 7, 4v by 7. But what is asked? My required ratio is the ratio of maximum speed to average speed. So, maximum speed to average speed, I will write this as ratio itself. Maximum speed is v divided by average speed is 4v by 7. And the answer is 7 by 4. Option C is right answer. Dear students, let us take one more problem on average speed. It is like this: a particle moving in a straight line covers half the distance with a speed of 3 meter per second. The other half of the distance is covered in two equal time intervals with speeds of 4.5 meter per second and 7.5 meter per second respectively. The average speed of the particle during this journey is options 4 meter per second, 5 meter per second, 5.5 meter per second and 4.8 meter per second. Dear students, I consider this as one of the most important types of problems since it is asked many a times before in many competitive exams. It is frequently asked. So, I request you to kindly practice more number of such problems. Here, this is based on average speed. The idea of average speed is quite simple: total distance covered divided by total time taken. So, here the entire journey is divided into two equal halves. Look at the problem. The first half is covered with a speed 3 meter per second, and in the second half of the journey again it is divided into two equal halves in terms of time. So, a diagram, a simple diagram will help me to understand the problem better. Look at this. If I consider that the total journey is 2s, then this part is s and this is one more s. I think this is advisable because if you take the total distance as s, you will have s by 2, s by 2. In order to avoid those two in denominators, this is a better idea to take the total distance as 2s, divide it into two equal halves, s and s. The first part is covered with velocity 3 meter per second, and in the second part the total distance is again divided. Let me say that this is divided into two equal halves, but remember this time it is in terms of time. So, the first half is covered with the time t and the second half is also covered in time t. Now, I'll say that the first half of the journey, this part is covered in time interval, let me say some t1. Now, what is your definition of average speed? It is total distance by total time taken. Total distance is 2s divided by total time taken is t1 plus t plus t, t1 plus 2t. I'll write the formula. Average speed is total distance is 2s divided by total time is t1 plus 2t. The ultimate idea is to find out t1 and t in terms of s, and that will be the end of the problem. How do I express t1 in terms of s? Look at the first half of the journey. Here, since it is uniform motion, distance is velocity into time. So, for the first half, distance s is equal to velocity into time. Velocity is 3 time t1. I hope it is clear. So, I want t1. t1 is s by 3. Now, I will go to the second half. During second half, take this time interval t. It is covered with a velocity 4.5 meter per second. Therefore, let me give symbols for these distances. This is S1 and this is S2. Let me say that this is S1 and S2. So, S1 is covered. This is second half I am talking about. Second half. S1 is, it is covered with a velocity 4.5, therefore 4.5 into time t. Similarly, S2 is covered with velocity 7.5 into time t. So, what does S1 plus S2 give you? The total distance is S again. So, I can always add these two S1 and S2. So, S1 plus S2 is 4.5 plus 7.5 is 12t, and that is equal to your S. So, I got my t. So, t is equal to S by 12. Now, have a look at your formula for average speed. 2S divided by T1 I got here, T also obtained here. So, by substituting I can find out average speed. So, that is the final step. Look at this, V average is equal to 2S divided by S by 3. T1 is S by 3, S by 3 plus 2 times S by 12, it is S by 6. I hope it is clear. Now, this is 2S divided by 6 being the LCM, this is 2S plus S is 3S and 6 goes to numerator. 12S, so S gets cancelled, 12 by 3 is 4. So, V average is 4 meter per second. Do I have an option? Yes, option A is the correct answer. But dear students, this is being the orthodox method of solving for average speed. I think it seems to be a lengthy method to solve. Instead of this, we have a shortcut to solve this problem also, and the shortcut is like this. I want you to remember two very important formulae for average speeds. Remember, average speed can be asked in two different ways. Type number 1, when the time interval is divided into two equal halves. I repeat, if a body goes from A to B and if the total journey is for 1 hour, and they will divide the total journey of 1 hour into two equal halves. That is, in the problem they will mention that the first 30 minutes is covered with a velocity V1 and the next 30 minutes is covered with a velocity V2. Then what is average speed? So, remember this formula, average speed in this case when time is divided is given by simply V1 plus V2 by 2. I repeat, V average is equal to V1 plus V2 divided by 2 when time is divided. Let me write that formula. So, V average is V1 plus V2 divided by 2 when time is divided. I have one more formula, that is when distance is divided. How do we divide distance? Same, when the particle moves from A to B and comes back to A. Here the total journey is divided in terms of distance. If that is the case, the formula is different. I will explain the problem once again. The body goes from A to B with velocity V1 and comes back to A with a velocity V2. Then what is average speed? In this case, V1 plus V2 by 2 will not work it out. Here the formula to be used is V average is equal to 2 V1 V2 divided by V1 plus V2. Remember this formula, it is V average is equal to 2 V1 V2 divided by V1 plus V2. This is the summary. Once again, when the time is divided, use this formula V1 plus V2 divided by 2, and when distance is divided, use this formula 2 V1 V2 divided by V1 plus V2. I would like to add one more point here. When the body goes from A to B and comes back to A, the average velocity will be 0 because the total displacement of the body will be 0 when the body comes back to the same initial point. Average velocity will be 0, but average speed will not be 0. It can be calculated using the formula 2 V1 V2 divided by V1 plus V2. Okay, can we use these shortcuts in this problem? Have a look at this, it makes the problem so simple. Let me take the second half first. Look at this second half. Here, the second half of the journey is divided in terms of time, two equal time intervals t and t. So, when time is divided, I can always go for the first formula, which is V1 plus V2 divided by 2. Okay, this is covered This part is covered with a velocity 4.5 meter per second and this is covered with a velocity 7.5 meter per second. So what is my average speed for the second part? It is 4.5 plus v1 plus v2 divided by 2. 4.5 plus 7.5 divided by 2, which is 12 divided by 2 is 6. I hope I am clear. The average speed for the second half of the journey is 6 meter per second. Okay, let me write it as, so for this part the average speed is 6, and what is the speed for the first half? It is mentioned, it is given to be 3. Now consider the total journey. What is divided? What is divided? Here the distance is divided. Yes and yes. When distance is divided, go for the second formula. V average is 2v1 v2 divided by v1 plus v2. So finally you can write it as 2 into v1 v2 3 into 6 divided by v1 plus v2. So this is 36 by 9 gives you 4. Here is the next question, dear students. A particle moves along a straight line such that its position x at any time t is x is equal to 60 squared minus t cubed, where x is in meter and t is in second. Then options: at t is equal to 0, acceleration is 12 meter per second square. B, xt curve shows a maximum at 4 second. C, both A and B are wrong. D, both A and B are correct. Dear students, this is based on the position equation of a body moving along a straight line. Here equation of position is given, using which we are supposed to comment on its acceleration. We always know that you differentiate the position equation, you get dx by dt, differentiate with respect to time, you get dx by dt, that is nothing but the velocity of the particle. And in order to get acceleration, differentiate the velocity equation once again with respect to time, that is dv by dt, or in other words d2x by dt2 will give you the acceleration. So x is equal to 60 squared minus t cubed, differentiate once with respect to time, dx by dt is equal to 12t minus 3t squared. So this is velocity. Then differentiate once again, d2x by dt2, that gives you acceleration, which is 12 minus 60. And what are we supposed to comment on? So find acceleration at t is equal to 0. At t is equal to 0, acceleration is 12 minus 0, it is just 12 meter per second square. I think option A is correct. At t is equal to 0, acceleration is 12 meter per second square. But what about option B? Here xt curve shows a maximum at 4 second. So we have an idea of maximum and minimum in any curve. A curve shows maximum when its slope is 0. I repeat, a curve shows either maximum or minimum when its slope is 0. So what is slope for xt graph? It is dx by dt. So to find maximum of xt curve, find dx by dt, which is already found out. I will write it once again. Dx by dt should be equal to 0 for maximum. So equate this to 0. So this should be 12t minus 3t squared is 0. So what is the result? So 3t square is equal to 12t, which means 3t is 12. This gives you t is equal to 4 seconds. What does this mean? This maximum happens at t is equal to 4 seconds. That is what given in option B. So what is the conclusion? A is 12 meter per second square and maximum at 4 seconds. Both options A and B are correct, and that is clearly depicted in option D. Option D is the right answer. Let's take one more beautiful problem, dear students. It's like this. From a tower of height h, a particle is thrown vertically upwards with a speed u. The time taken by the particle to hit the ground is n times that taken by it to reach the highest point of its path. The relation between h, u and n is options 2gh is equal to nu square into n minus 2, gh is equal to n minus 2 into u square, 2gh is equal to n square u square, and gh is equal to n minus 2 whole square into u square. To solve this, let us consider the tower first. Let me say that this is that tower of height h and the ball is thrown upwards. This will be its trajectory. It reaches a maximum height here and comes back and hits the ground. And according to the given conditions, time taken by the ball to reach its peak is, let me call this time as some t1 from here to peak, and the other time is the time taken by the ball to reach ground. Let me call it as t2. t2 is for whole journey, remember, for the complete journey t2. According to the given condition, t2 is n times t1. This is the condition given. Let me consider the t1 portion first, that is from the top of the tower to the peakest point. For this upward journey, I will use v is equal to u minus gt. As we know, at the peak final velocity is 0, therefore u is equal to gt, or gt is equal to u, and I have considered that time as t1, which will be t1 is equal to u by g. Keep it as it is. Now let us consider the whole journey. For the complete journey, the total displacement would be from the top of the tower to the ground. It is, the displacement is the shortest distance between the initial and final position, which is h, and according to a sign convention, since this h is the downward direction, it has to be taken as negative. H is equal to, using s is equal to ut plus half at square, u into time taken is t2 minus half g t2 square. I am quite sure that you all are familiar with this negative sign. G is always taken to be negative since it is downwards. I repeat, G is always negative irrespective of the direction of motion of the body, whether it is upward or downward. G is always negative. That is why it is negative here. And let me multiply by negative sign straight away. H is equal to half g t2 square. What is t2? N t1, n times t1. So this will be n square t1 square. This will be minus u into, what is t2 again? N times t1. I think this step is clear. Now I will substitute for t1 from this. This is half g n square into t1 square is u square by g square minus u n into t1 is again u by g. So let me take this g gets cancelled with 1g and n square u square. Here I have n into u square. So let me take n into u square common and g is there. There is 2 here. Let me take the 2 also in the common factor. So in the first time I am left with n minus, there was no 2 here, so 2 comes in numerator, n minus 2, right. N into u square is taken outside, g is also taken outside. So in my LHS I have h. So cross multiplication will give you 2gh is equal to nu square times n minus 2. I think option A is correct. let's take up a beautiful question, dear students. A student is standing at a distance of 50 meter from a bus. As soon as the bus begins to move with an acceleration of 1 meter per second square, the student starts running towards the bus with a uniform velocity u. Assuming the motion to be along a straight road, the minimum value of u so that the student is able to catch the bus is options 5 meter per second, 8 meter per second, 10 meter per second and 12 meter per second. Dear students, I have seen many students, college students, boys especially, allowing the bus to go farther and farther away and then chasing the bus and finally catching it like a hero. Right, this is one such problem, and let me say that the boy catches the bus after a time t. Let me write their positions first. If here is where the boy stands and bus is here, the distance between boy and bus is 50 meter and bus starts accelerating and it moves in this direction. Let me say that boy starts running from this point and finally catches the bus here. So let this entire drama happen within time t. So during this time interval t, remember, according to the given problem, the boy runs with uniform velocity u. So what is the total distance covered by the boy? It is uniform velocity into time. S is equal to u into t is the distance covered by the boy. So distance covered by the boy is u into t, and in order to catch the bus, how much distance should he cover? He is already 50 meter behind the bus, and during this time t, the bus also moves starting from rest. So what is the distance covered by bus? Distance covered by the bus is so much. This can be calculated using s is equal to ut plus half at square. Here initial velocity is 0, so it is just half at square, and the acceleration of the bus is given to be 1. So the distance covered by the bus is, I'll write directly here, it is half at square. The value of a is 1. So in order to catch the bus, the distance covered by the boy ut should be equal to this distance plus this distance, that is 50 plus half at square. I hope I am clear. So at this point, the total distance covered by the boy is ut, which should be equal to this 50 plus half at square. A is 1. So I am supposed to find out the value of u. So let me take the t to the other side. U is equal to 50 by t plus a is 1. So it is t square by 2 divided by t is t by 2. Here this is the expression for u. It is the velocity of the boy who is trying to catch the bus, and look at this, it is a function of time t. What does it mean? In order to catch the bus, the velocity to be selected by the boy completely depends on himself. He can choose any velocity that he wants, because if he wants to run like Usain Bolt, he can easily catch the bus. But according to the given condition, you need to set up a minimum possible value for u. So if you run slowly, it takes longer time to catch the bus, obviously. If you run fast, you can catch it faster, earlier. So here the condition says that u should be minimum. U is a function of time, u should be minimum, and we know the condition for minimum. For minimum, du by dt should be equal to 0. I repeat, for minimum, du by dt is 0. Here I have u in terms of t, differentiate this with respect to time t and equate that to 0. So for minimum, du by dt is 0. Differentiate this with respect to t, which is minus 50 by t square plus half is equated to 0. That is 50 by t square is half, t square is 100. This gives me t is equal to 10 seconds. What does this mean? The boy catches the bus after time 10 seconds. But what are we supposed to find out is the velocity with which he has to move in order to catch the bus in 10 seconds. Just substitute t is equal to 10 in this equation. So I'll get u is equal to 50 by 10 plus 10 by 2. It is 5 plus 5, 10 meter per second. Do we have this option 10 meter per second? Yes, option C is right answer. This is not a bad velocity either. 10 meter per second in 1 second. If he runs for 10 meters, then for 100 meter he just takes 10 seconds, almost close to Usain Bolt's velocity. Okay, I think option C is the most correct answer.